charge is actually equal to the total charge of the electron. So he said that atom is electrically neutral. Okay, got it. But what he said in the next one is that when he was doing the experiment, the gold leaf experiment was done by, sorry, gold leaf experiment was done by, who did the gold leaf experiment? Tell me, who did the gold leaf experiment? Goldstein. Okay, and what does he said in the gold leaf experiment? So let me show you here. Just a minute. Okay, so this was the gold leaf experiment actually, and what he said in the Rutherford model of gold leaf experiment. Okay, he did this experiment. He did this experiment, and there was some alpha particle emitter. So there was alpha particles. Okay, this is the alpha particle emitter, or we can say there is a machine that is, or there's something which is producing the alpha particles. Okay, so this is the alpha particle emitter. Alpha particle emitter. Okay, so what did this alpha particle emitter do? He is just means scattering, or we can say that it's just emitting the alpha particles, and he find that most of the alpha particles passes through a straight lines. Okay, most of the alpha particles pass through the gold file undeflectedly. Gold file. Why he was choosing gold file? Because the atoms of gold is much bigger than the size of the alpha particle. So alpha particle can pass through the gold file. Atoms of gold file. Okay, so gold file is bigger in size, alpha particle is smaller in size, so alpha particle can easily penetrate through atoms of gold file. Okay, so he said that most of the alpha particle pass through the gold file undeflectedly. And how he was observing this one? He was observing this one with the help of zinc sulfide screen. He was having a zinc sulfide screen here. Okay, and this zinc sulfide screen where they were deflected, so he was just able to, that he was just showing this one, the most of the alpha particle are striking here. Okay, so it means that they are traveling in the straight line. Some of the alpha particles strike here. Okay, so they mean they are not traveling in a straight line. Okay, some of the alpha particle rebound back. He also put the alpha particle, okay, zinc sulfide screen here. So if they are rebounding back to its original path, so it means that, are you getting my point? So we see here that one out of 12,000 particles appear to rebound. Okay, so most of the alpha particles passes undeflectedly. Some of the alpha particles are deflected by small foil, small angles, and the one out of 12,000 alpha particles rebound back. Okay, so please note it down. Please note it down. Note it down. Done this one?
No, sir.
Note it fast.
I'm doing.
Make it fast. So let me show you this one. Just a minute. So please, you can check this one here. Okay. The students are able to see this one. Are you able to listen this one? Tell me
Sir,
fast.
you can't see anything.
It is nothing visible to you.
Yes,
Okay,
sir.
just a minute. Just a minute. Just watch this one. Is it visible to you now?
Yes, sir.
Is it? Okay, now watch this one.
One of the most pivotal experiments in the history of physics, the gold foil experiment. In the early 20th century, J. Thomson, a brilliant physicist, sought to uncover the structure of the atom. He defined an atom's structure as a plum pudding uniformly distributed positive charge with negatively charged electrons embedded within. You must understand that before plum theory, the actual structure of the atom was a total mystery. This was the first time that someone explained the structure of the atom. But this theory wasn't tested in an experimental phenomenon. Ernest Rutherford, a well-known physicist of that time, took it upon himself to test this theory. Rutherford, along with his collaborators, designed a groundbreaking experiment that would challenge this existing model and pave the way for a new understanding of atomic structure. The experiment involved firing alpha particles towards a thin sheet of gold foil which was surrounded by a thin film of zinc sulfide. Since alpha particles are very small positively charged particles, they are not observable by a naked eye. The zinc sulfide screen around the gold foil will help detecting their landing point, since it will glow when an alpha particle collides with it. According to the prevailing model, the alpha particles should have bounced back mostly, given the assumption of a plum-shaped uniformly distributed positive charge. However, the results of the experiment were astonishing. Most alpha particles passed straight through the foil, but a small fraction deflected at various angles, interacting with negatively charged electrons. And only 1 in 12,000 alpha particles changed their direction 180 degrees. This unexpected pattern of deflection led Rutherford to propose a new atomic model, the nuclear model. The nuclear model suggested that atoms have a tiny, dense, positively charged nucleus at the center, surrounded by mostly empty space through which electrons orbit. If we were to compare atoms' nucleus's size to the whole atom, it would look like a dust particle in a large room, which proved that atom is mostly empty. Further, the deflections of the alpha particles indicated that the positive charge and mass of an atom were concentrated in a small nucleus, which explained the 180-degree deflections of the alpha particles. Rutherford's discovery revolutionized our understanding of atomic structure and laid the groundwork for further exploration into the subatomic world. The gold foil experiment remains a cornerstone in the history of science, fundamentally altering our perception of the atom and inspiring.
So actually what he does here is that, okay, So we need to keep in mind here that what he does, he did a gold leaf experiment in which he made a circular zinc sulfide screen which is glittering, which is actually glittering, and we can say that which is helping actually to know where these are being represented, okay, or where the electrons are being uh, moving, okay. So you need to keep in mind here that in his experiment, okay, just a minute. What he was doing, he is the screen is visible to you now? Are you getting my point? So when Rutherford model was done, so what was the explanation of the Rutherford model? We need to understand this one. That how we can say that Rutherford model was successfully able to explain, or what and how it is successfully able to explain that the atomic structure is not that is given by the Rutherford, sorry, J.J. Thomson, that is the positively charged pairs and electrons are embedded in it. No, actually, that was given by Rutherford and by his gold leaf experiment. What he said actually, that most of the alpha particles were moving in a straight line. Okay, so this is the atomic structure. So most of the alpha particles were moving in a straight line without any deflection. So okay, this is an atom of gold. So they are the most of the alpha particles were moving in a straight line. So this means that the conclusion of this one is means that atoms is means we can say that there is a lot of empty space in the atoms, okay. There is, indicating that there is a lot of empty space in the atom. Got it? And if some of the particles are being deflected, for example, some of the particles are moving like this, alpha particles, and they got deflected, okay, to some angles, means there is some positively charged substance present through which the alpha particles are being deflected, and electrons also, because alpha particle is positively charged particle, okay. So if there are electron present, so they are attracted towards electron, okay. So example, if there is electron present here, and if a particle is moving like this, so it will be deflected towards the electron. Got it? So we can say that there is some charged particle present inside the atoms, if like the electron and protons are present, okay, and if they are deflected, means alpha particles are positively charged, and positively charged particles are deflected by the negative and positive. If this is a positive charge nucleus, so it will, when alpha particle move, any positively charged particle move, then it will be deflected away from it. And if there is electron here, so it will be deflected towards it. It will be deflected towards it, okay. So because of the presence of electrons and the positively charged proton, the alpha particles are deflected to some small angles, and 1 out of 12,000 alpha particles rebound back to its original path at 180 degrees. This indicates that there is something dense and hard substance present in the center of the atom through which alpha particle cannot penetrate. Means this is very hard for them to penetrate that hard substance, and he named it as nucleus. And he named it as nucleus. Understood? So how was nucleus discovered? Because the 12,000 particles, out of 12,000 particles, only the one alpha particles was coming back to its original path. This indicate that alpha particles cannot penetrate through the there is something hard and dense substance present in the center of the atom, and through which alpha particle cannot penetrate. Okay, got it? Understood? Tell me
Yeah.
fast. Understood? Okay.
Yes.
So this was the model of Rutherford that, okay, that he was getting. And what was the conclusion of this one? So let you write it. Okay, just a minute. The conclusions of Rutherford model. So note it down. What was the conclusion? From his observation, Rutherford draw the following conclusion. The first conclusion was, he said that atoms, most of the alpha particle moves in okay, without deviation, without they move in a straight line. So it means that atoms has most of the alpha particles pass through the gold fire undeflectedly, means atoms has predominantly lot of empty space. Okay, the atom consists of the conclusion of the first thing that the most alpha particles moves in a straight line. This means that atoms has predominantly lot of empty space. Okay, got it? Got it? The second conclusion was the second conclusion was the second conclusion was that atoms contain centrally, or means we can say that there is that out of 12,000 particles, one particles was rebonding back to its original path. This means atom contains centrally placed positively charged nucleus. Okay, or we can say that positively charged particles. Okay, and because of a few alpha particles scattered or deflected at few angles. Okay, so they are deflected. So how they are deflected? Because there is some positively charged particles. So atom contains some centrally placed positively charged nucleus, and because few alpha particles suffered or deflected, means there is something that is positively charged present in the center of the atom through which alpha particle cannot penetrate. Okay, so you can write this one in the simple language. Let me help you to write this one. That atom consists of, don't write this point, write my points, what I'm writing here. Okay, for the second points, that atom consists of, or let me write it. Okay, let me write it on the next page. Conclusion for out of 12,000. So out of 12,000, one alpha particle rebond back to its original path, indicating that out of, sorry, indicating that there is something hard and dense present in the atom through which alpha particles can't penetrate it. Okay, and he named it nucleus. He named it as nucleus. So note it down. Done this one?
No, sir.
Noted? Noted
No,
fast.
sir.
Out of 12,000, one alpha particle rebound back to its original path, indicating that there is something hard and dense substance present in the atom through which alpha particle cannot penetrate. He named it as nucleus. Okay. And what was the conclusion of the second point? That some of the alpha particles deflected at small angle. Deflected at some small angles. So what is the conclusions of this one? What was the conclusion? Tell me, what was the conclusions? So the conclusion of this one, there is something hard and dense substance present. There is some charged particles. So here said that since a minute fraction of alpha particles suffered deflection and very few bonded back, this led to the conclusion that the most of the space and the atoms are empty, and the space occupied by the nucleus is negligible as comparison to the empty. Okay. So if we consider this one, that since only the 12,000 particles, out of this 12,000 particles, uh, only one particle is rebonding back, this means that the nucleus is very small in size. Nucleus is very small in size. Okay, so please note this third point. Since a minute fraction of alpha particles suffer deflections and very few bonded back, so I'm just doing this one in short. Wait a minute. Note it down. A minute fraction of alpha particles rebound back. Conclusion that most of the is empty. The nucleus is negligible as comparison to this empty space. Only write the underlined part.
Sir, is this the continuation of the third point?
Yeah, no. It is the how you can say it is the continuation of third point. Or make a different point. It's your choice. Done.
No, sir.
And the next one is that this note it down. The size of the nucleus is about 10 raised to the power minus 5 times the size of the atom. And the whole mass of the atom is concentrated in the nucleus. Means we consider that the whole mass of the atom is in the nucleus. Almost all the mass is in the nucleus. Okay, so note this part also. Whole mass is concentrated in the nucleus. Note it down fast. Whole mass of the atom is about 10 to the power minus 5 times the size of the atom. Done? Noted? Okay. So, and he was also that a few particles deflected at small angles. So what does mean? Some of the particle deflected at small angles. It means that there is some charge particle present in the atom through which positively charged alpha particle is deflected. Noted? Done?
No, sir.
Okay. Noted fast. Now, if I talk about this one, that what is the uh, on the basis of this observation, uh, Rutherford also gave his model. Okay, and what he said in his model, that he said that the atoms consist of some positively charged particles or positively charged nucleus at the center, and the electrons revolves around it. Electrons revolve around it. Okay, what he said? He said that atom consists of some positively charged particles and electrons revolves around it. Okay, electrons revolves around it. So what he said, and in a fixed orbit, okay, in a fixed orbit, the electrons revolve around it, and the size of the atom is very, very small as comparison to the size of the atom. So what he said in his features or in his experiment actually, so on the basis of these observations that you write here, so please note it down here. That on the basis of his observation, what he said actually, on the basis of the experiment, Rutherford proposed a model of atom. Okay, so write it on the basis of his experiment. Rutherford proposed the model of atom, and with the following features, having the following features. First, he said that there is a positively charged nucleus. Okay, there is a positively charged nucleus in an atom. Okay, nearly where the whole mass of the atom is, means whole mass is there. Means what he said, that he said that there is positively charged nucleus at the center of the atom where the whole mass of the atom is concentrated. So you can write it, there is positively charged nucleus in an atom where, okay, and nearly all mass residue in the nucleus. Okay, that means the total mass of the atom is in the nucleus. Okay, or so you can write it, nearly all mass lies inside of resides, you can write lies in the nucleus. Okay, so nearly all mass lies in the nucleus. The second point, he said that electrons revolve around the nucleus. There is electrons and they are revolving around the nucleus in a fixed orbit, in fixed well-defined orbit they are revolving. The third one is size of the nucleus is very small as comparison to the size of atom. Size of the nucleus is very, very small as comparison to the size of the atom. Note it down, fatafat. Okay, note it down. Done? When you're done, please let me know, okay? Done this one?
It's just last.
Is there anyone who's writing? Is there anyone who is still writing?
Done, sir.
Okay. So next, what was the drawbacks? Drawbacks of what was the drawback? Drawback of his structure. Drawback of Rutherford model. This model was not correct. Okay. Of Rutherford model. What was the drawback? The first drawback is that in the Rutherford model, actually, when a charge, he said that nucleus is present, a positively charged nucleus is present at the center, and electron revolve around it in a fixed orbit. But actually, according to the Maxwell theory, okay, according to Maxwell theory of electromagnetism, when a charged particle revolves around an uncharged particle, then or charged particle, then it continuously loses its energy. Okay, and then electrons is going to have very less energy, and it will take approximately 10 raised to the power minus 9 seconds. This is very small time. Means 1 upon 100 crore. Means if you break the atoms, or sorry, 1 second into 100 crore parts, okay, 100 crore, then in one of these of that fractions, okay, we can simply say that this is very small, very small time. Okay, so the atom electron will lose its all energy and it will collide with the nucleus. Okay, it will collide with the nucleus, which make this atom unstable. Actually, it does not happens in the real life. Atoms are stable and they do not, the electrons are not colliding in the electrons do not collide in the atom, or sorry, in the nucleus. So this was the drawback. This is our first drawback that he was not able to explain, that when an electron revolve around the nucleus, then it will continuously lose its energy and will collide with the nucleus, and the atom will become unstable. Okay, so this was not explained by Rutherford, that why what was, and this was a major drawback of him. So please note the drawback of Rutherford model, that according to Rutherford model, when electron revolve around the nucleus in well-defined orbit, but electron being charged particle will lose its energy and finally fall into the nucleus in, note it down, in 10 to the power minus 9 second. This make atoms highly unstable, and this was the major drawback of Rutherford model, which he was unable to explain. He was not able to explain it. Okay, so please note it down. Done, everyone?
No, sir.
Done, everyone? Done? Noted? Okay. Okay. So what we're going to study next is what was the drawback of J. Thomson model? Drawbacks of J. Thomson model. Actually, he was not able to explain that the Rutherford Goldleaf experiment. Okay. So actually, if I talk about the J. Thomson model, J. Thomson model. So he said that atom is positively charged sphere. Okay. So if it is positively charged sphere, then according to the Goldleaf experiment, atom is not going to be a positively charged sphere. It is going to have a nucleus which is present in the center of the atom. And because of that, only 12,000 particles, 1 out of 12,000 particles are alpha particles are rebonding back to its original path. So this is only possible. This is only possible when atom is going to have some positively charged dense substance inside the atom, and which he called it nucleus. And it is only possible which is if this nucleus is very small in size and if it is positively charged. Okay, so the concept of that sphere is positively charged and electrons are embedded in it. So this was not means this model was failed and was not able to explain the Goldleaf experiment conclusions or Goldleaf experiments. Okay, observation of Goldleaf experiments. So the drawback of J.J. Thomson model is that that his model was not able to fit according to the observation of Rutherford Rutherford Goldleaf experiment. Got it? And he was the concept of nucleus. The concept of nucleus was not given by J.J. Thomson. So this was the major drawback that he was not able to explain. Okay.